Make sure you read your directions on here. It doesn't say just a graph. There's another part at the end of it. So while most of it's review, there is one small thing that's new. And it does focus on, well, what do the points actually mean when they're on a line? So we all know you start at -2 on the y-axis, down here. And then if we have a slope of 2, that's the same as 2 over 1. Rise of 2, run of 1. And up 2 over 1, no problem. We're doing this for quite a while yet. But the second part says, show a coordinate on the line is a solution. So what you're going to do is that you can pick any coordinate that's on the line and plug it back into the original equation. In this case, it's y equals, and you always plug into the original equation. So here, I'm going to pick, let's say here, I'm going to pick this coordinate. I can pick any one of them, but I'm going to pick this one, 3, 4, and plug it in my x, my y, into x and y. So I have 4 equals 2 times 3 minus 2. And when I simplify this, I should get a true statement. Like 4 equals 4 is true. And what does this actually mean? Okay, and this is probably the most important part. It means that 3, 4 is a solution because it came out to be something true. And you can pick any point. Some of you might say, well, I'll pick something with a 0 in it because sometimes multiplying by 0 and adding 0 is a little bit easier. So that's fine. And what does it look, this part, I'm going to also show, well, what does it look like if it's not a solution? So plug in something not on a line, right? And you'll have 0 equals 2 times 0 minus 2, and you get something that is false. Okay. False. And that's how you know that 0, 0 is not a solution. And this will be asked on your quiz on next Thursday or Friday when we take it. Graph it. Graph the equation, graph the inequality, and give us a coordinate that is a solution and give us a coordinate that is not a solution. So you have to know what it means to be on the line or not on the line for equation. And then when we go down, let's go down 5, that we have a equation that is not in slope-intercept form, right? So recall that we need to get y by itself. We got to get rid of 9x and then divide by 5. So positive 9x, so subtract 9x. So we have 5y equals negative 9x plus 20. And then divide everything by 5. Y equals negative 9/5 x plus 4. 20 divided by 5 is 2. Some more practice. 4, go down 9, right 5, use a straight edge. And what point would be good to try here? That's on the line for sure. Okay, 5, -5, or 0, 4. So either one of these will work. Which one would you rather use?
0, 4.
Yeah, whatever you want is fine. Make sure you plug it in though to the original equation. So into this one. The thing is, if you haven't made a mistake in all this work, and you plug it in there and it works, but you made a mistake, it's going to give you a true answer, but it'll end up being wrong because your equation is wrong. So always plug in, when you're checking, into the original equation. So 9. So we have x is 0, y is 4, and then pretty quickly you can see 0 plus 20 is 20, and it does check out. And that is true. So we know for sure 0, 4 is a solution, and we know we can use any other point not on the line, like 0, 0, and if we plug that in, we get something false. So make sure you do this step for every one of these on the front, along with the graphing. Any clarifications needed on this? Okay, flip it over to number 7. Now here, it's the same thing as before, but we have an inequality. So first start off, how do you say this sign out loud?
Y is greater than 7/4x minus 2.
So that's greater than. Still have some people that will mix up greater than and less than. We have to know this means greater than. Think of it on the number line. Right? Pointing this direction, these are all what the bigger numbers are. Everything is bigger to the right, everything's smaller to the left. So it points to the direction it indicates. So if it's pointing to bigger numbers, that's a greater than. If it's pointing to the small numbers, it's a less than. That's why we have this symbol. It's very deliberate. Can't mix it up. Keep in mind though, what we're used to is probably this open circle and closed circle, and it goes to the left, it goes to the right. This is true if you're dealing with the x-axis. Right? It's left and right. But if you're dealing with the y, it's up and down, because the y-axis goes up and down. So we're going to be going up and down, not left and right. Let me show you what I mean. Okay, so here, like I just mentioned, we're used to doing this on one axis, and it's left and right. We're dealing with two axes now and dealing with y. Okay? So for instance here, how will we graph this? And I'll talk about what this symbol does to the problem. First of all, basically just start off as an equal sign. So that's what we did on the front. We go through that and find the y-intercept, and we use the slope, go down 3, right 1. Okay. However, we're going to have something quite different. Okay. You are going to have this. Write this down on the back or somewhere on there, this guide, and I'll let you know what to do for each of the 4 inequality symbols. So for instance, if it's greater than or equal to, I know I should draw a solid line and then shade above. Remember, we're not going left and right. We're going up and down because it's the y variable, which is up and down, vertical. But if it's just without the equal to, then something different than we're used to. You're not going to do a solid line. You're still going to use a straight edge, but you're going to use a dashed line. And it's the equivalent of an open circle. This means that particular point on the line is not a solution. So if you plugged it in into the original equation, it would not be true. I'll show you what I mean in a minute. Okay, but this will help you a lot. Have it on the homework so you can look back and forth, and eventually you get so sick of looking back and forth, you'll just memorize it and you'll do that. But it's kind of intuitive. Solid line is the equal to, has a solid line. The equal to part, think of it as a solid line. The shade up are the greater thans, the shade down are the less than, so it should be pretty intuitive. not a matter of memorizing, but just understanding. Okay? So in this particular problem, okay, it's a greater than or equal to, so that means I need a solid line. And then you go on any point and you go straight up. That's the side that you shade on. Now be careful that don't say this is shaded right. It's actually shaded up because it's the y-axis, it's the y variable. So we're shading above the line. Okay. And now when you do the shading, you don't have to make it so exact and shade it all perfectly. Just make it obvious that this is the side where all the solutions are. Okay. Now what's different from what the front of the worksheet we just started is, you can plug in any of these, not just the ones on the line, but any of these, and it'll be true. Okay? It'll be true. So going back here, go ahead and graph it. So start -2 and go up 7, right 4. Up 7, right 4. Is this, according to the chart, is this solid or dashed? Dashed. So be careful here. Don't just automatically draw still use a straight edge, but don't automatically draw a solid line. Still use the arrows at either side. And should I shade above or shade below? According to the chart? Above, yes. Now, when you're doing this, this is fine right here. You can just do this. If you want to take the time and color it in perfectly, please finish all the work first and then go back and do that. Don't waste a lot of time just coloring it in. So that means any of these are solutions. Now, what is the easiest point in the shaded region to plug back in? 0, 0, yeah. So anytime 0, 0 is in that shaded region, use that. Because you go 0 greater than, and then you still have to do this, so make sure you do this, 7/4 times 0. See, by using 0, 0, sometimes people don't like to multiply by 7/4, but when you multiply by 0, it's pretty easy. It's just 0. So the question is the same. Is this true or false? Is 0 bigger than -2?
Yeah.
That's true. Therefore, we did shade the right side. Okay? So always choose something in the shaded region. If it came out to be false, it means I shaded the wrong side or I drew the line wrong. Okay? And if you shaded, you plugged in something on the line, last thing right here. If I plugged in something on the line, I'd get this. Is this true or false?
False.
This is false. This is why it's dashed, because -2 is not bigger than 2. That's why it's dashed.